Close your eyes for a moment and picture yourself standing on the shore of an endless ocean, with nothing but the wind in your hair and the vast, star-filled sky above you. There are no glowing screens, no satellites guiding your way, no reassuring voice telling you to turn left in 500 feet. For the ancient mariners who first ventured into the unknown, this was reality, a world without any of the technology we take for granted today, yet they achieved what seems almost impossible to us now. They crossed thousands of miles of open water, discovered new continents, and built trade networks that spanned the globe using nothing but their knowledge of the stars, the behavior of the waves, and maps that were as mysterious as they were accurate. What if I told you that these early explorers possessed a kind of genius we're still struggling to fully understand? A hidden code, woven into oral traditions, etched into artifacts, and whispered on the wind, that allowed them to navigate the planet with a precision that sometimes rivals our own. This is the story of that unknown code behind lost maps, and how civilizations from the Polynesians to the Phoenicians, the Vikings to the Arab traders, unlocked the secrets of the natural world in ways that feel almost magical to our modern minds. They didn't have compasses or GPS, but they had something perhaps even more powerful, an intimate, deeply cultivated relationship with their environment. They could read the language of the stars, sense distant land by the behavior of birds, and interpret ocean currents like pages in a book. Their maps weren't just drawings, they were living, breathing guides that blended astronomy, mythology, and sheer human intuition. And yet, so much of this knowledge has been lost to time, leaving behind fragments and mysteries that tease us with questions we're still trying to answer. In this video, we're setting out on a journey to uncover how these early masters of the sea accomplished such breathtaking feats of navigation, and why their methods remain so difficult to recreate, even with all of our advanced technology. We'll explore celestial navigation, oral traditions that preserved star paths for generations, and artifacts like the puzzling Piri Reis map that continue to mystify historians. We'll meet the wayfinders who could feel their way across the Pacific, and the traders who guarded their routes like state secrets. This isn't just a history lesson, it's an invitation to rediscover a forgotten layer of human ingenuity, and to reflect on what we might have lost in our rush toward digital convenience. So come with us as we dive into one of history's most captivating puzzles, and uncover the hidden wisdom that connected humanity long before the first satellite ever touched the sky. Think about the very first time a human stood on a shoreline, gazing out at an endless expanse of water and wondering what lay beyond the horizon. That primal curiosity, that burning desire to see what's on the other side, is one of the most fundamental traits we possess as a species. It wasn't about having the right technology or even knowing what they would find. It was about an irresistible urge to discover, to push past the boundaries of the known world. This innate drive to explore is the very bedrock upon which all ancient navigation was built. It was fueled by a combination of necessity and wonder, the need for new resources and trade opportunities, the search for new lands as populations grew, and a simple, profound sense of wonder about the world. Civilizations didn't just stumble into exploration, they were compelled by it, and this compulsion led to some of the most daring journeys in human history. Consider the Polynesians, who began spreading across the Pacific Islands over 3,000 years ago. They set out in double-hulled voyaging canoes, facing the largest ocean on the planet with no guarantee of finding land. Or the Phoenicians, who built a formidable maritime trade network across the entire Mediterranean Sea, establishing colonies and trading ports from North Africa to the Iberian Peninsula. Then there were the Vikings, who braved the treacherous North Atlantic in their iconic longships, reaching Iceland, Greenland, and even the shores of North America centuries before other European explorers. What's truly remarkable is that these cultures existed in isolation from one another, yet they all arrived at the same conclusion: the sea was not a barrier but a pathway. They shared a fearless spirit that refused to be bound by the shorelines they were born on. But to call these early explorers mere adventurers would be a tremendous understatement. They were brilliant strategists and keen observers of the natural world. They didn't just wander aimlessly into the blue. They developed highly sophisticated systems of knowledge long before the invention of written maps or magnetic compasses. This knowledge was a form of intellectual currency, meticulously gathered and, most importantly, passed down through generations. Elders taught the younger generation how to read the subtle signs of the environment, the specific flight patterns of birds returning to land at dusk, the way ocean swells changed direction as they wrapped around distant islands, the smell of certain blossoms carried on the wind from faraway shores. This was not guesswork, it was a science of observation, a cumulative body of wisdom that allowed them to construct detailed mental maps of their world. These mental maps were living, evolving entities, constantly updated with each new voyage, and woven into the fabric of their cultures through stories, songs, and chants. A Polynesian navigator, for instance, would memorize a vast catalogue of star paths, knowing exactly which star would rise over a particular island at a specific time of year. This knowledge was so precise and so deeply ingrained that a master navigator could point to the location of an island countless miles away simply by feeling the movement of the waves beneath his canoe. This was the dawn of cartography, not ink on parchment, but knowledge etched into memory, a celestial and oceanic roadmap that was both practical and sacred. This foundational work, this fearless venturing into the unknown using only the mind and the senses, set the stage for every navigation system that followed. It hints at a deeper code, a way of seeing and understanding the world that we are still striving to fully decipher today. Now, let's turn our gaze upward to the one tool that was always available, always reliable, and breathtakingly vast: the night sky itself. For these ancient mariners, the heavens were not a distant tapestry of light. They were a dynamic, rotating chart, a celestial dome etched with pathways to every corner of their world. Without this cosmic map, long-distance voyages across featureless oceans would have been utterly impossible. Their understanding went far beyond simply following one bright star. It was a complex, living science of astronomy practiced under the open sky. The North Star, or Polaris, was a crucial anchor point for many Northern Hemisphere cultures like the Vikings and Phoenicians, because it holds a nearly fixed position almost directly above the Earth's North Pole. It provided an unwavering reference. By measuring the angle between the horizon and Polaris, a navigator could estimate their latitude, how far north or south they were. But what about when they traveled too far south for Polaris to be visible? This is where other constellations came into play. In the Southern Hemisphere, the brilliant Southern Cross and the two pointer stars, Alpha and Beta Centauri, served a similar guiding purpose. Navigators would imagine a line between the long axis of the cross and use it to find the south celestial pole, their own fixed point in the swirling night. But the true masters of this stellar science were the Polynesian wayfinders. Their knowledge was so refined that they didn't just see constellations. They memorized the precise rising and setting points of hundreds of individual stars on the horizon. Imagine the ocean as a vast circular plate and the horizon as its rim. A skilled navigator would know that a specific island always lay in the direction where a certain star, say Arcturus, rose each evening. As their canoe moved through the night and that star's position shifted, they would then hand off their course to the next star rising in the same house, a term they used for these directional sectors. They effectively created a mental star compass dividing the 360-degree horizon into 32 directional points, each marked by a celestial body. This allowed them to sail a straight course through the darkness, maintaining their bearing long after their departure island had vanished beneath the waves. This celestial navigation was never used in isolation. It was seamlessly woven together with a profound reading of the ocean itself. During the day or on overcast nights when the stars were hidden, they turned to other natural signposts. They became experts in ocean swells, the large, rolling waves generated by distant weather systems. A seasoned navigator could feel the specific rhythm and direction of these swells through the hull of the canoe, using them like underwater rails to stay on course. If a new swell pattern interfered, it might indicate an approaching storm or, more hopefully, the presence of a landmass disrupting the ocean's flow. The behavior of birds was another critical clue. Certain species, like the tern, fly out to sea to fish in the morning and return to land at dusk. Spotting these birds and noting their flight direction could lead directly to an island still far beyond the horizon. They even learned to read the sky, noting how clouds often gather or take on a greenish tint over lagoons and islands. This multi-layered approach, combining the constant stars with the living ocean, created a fail-safe system of wayfinding. It was this incredible synthesis of knowledge that enabled the settlement of the most remote islands on Earth, a feat of exploration and memory that we, with all our technology, are only now beginning to fully comprehend. Now imagine holding all of that celestial knowledge not in a book or on a device, but entirely within your own memory, passed down through generations not by text, but by word of mouth and lived experience. This is the heart of the Polynesian wayfinding tradition, a system of navigation so profound and so deeply interwoven with culture that it represents one of humanity's greatest intellectual achievements. Without a single written map, these master navigators, known as wayfinders, undertook voyages across thousands of miles of open Pacific Ocean, guided by an intricate oral library of information encoded into chants, stories, and songs. This living repository was known as the Kaʻiʻapu, a term that encompasses not just the words themselves, but the entire rhythmic, performative act of passing on this sacred knowledge. It was through the Kaʻiʻapu that a master would teach his student the precise star path to a specific island, the unique feel of the waves as they bent around a particular atoll, and the song of the wind that blew only from the east during harvest season. This wasn't just memorization, it was the total immersion of the student into a holistic understanding of the world as a navigator sees it. Each chant was a mnemonic device, a carefully constructed verse that packed generations of observational data into a form that was both beautiful to recite and impossible to forget. The rhythm of the chant might mimic the rhythm of the waves, helping the navigator internalize the pulse of the ocean. The stories weren't mere myths, they were data storage, embedding crucial information about seasonal weather patterns, animal migration routes, and the appearance of certain stars within narratives of gods and heroes. This oral code ensured the survival of this priceless knowledge for centuries, making each successful voyage not just a journey across water, but a reaffirmation of cultural identity and ancestral wisdom. The prowess of these wayfinders seems almost superhuman to our modern sensibilities. Take the legendary navigator Piʻailug from the small island of Satawul in Micronesia. In the 1970s, at a time when this ancient art was nearly extinct, Mao stunned the world by successfully navigating a traditional voyaging canoe, the Hokulea, from Hawaii to Tahiti, a distance of over 2,500 miles using only the old ways. He did this without a compass, without a sextant, without any instruments at all. How was this possible? Mao spoke of feeling the ocean through the canoe. He could discern the faintest reflected swell, a wave that had bounced off a distant island and traveled back out to sea, creating a subtle interference pattern in the dominant swell direction that he could sense through the hull. He read the sky like a map. Certain types of clouds gather and stall over land, while the undersides of clouds might glow with a faint greenish tint, a reflection of the lagoon water from an island still well beyond the visible horizon. He listened to the ocean as well. The presence of certain birds like the monu-o-ku or white tern, which flies out to sea to fish but must return to land each night, told him that an island lay within a specific radius. His entire body was a calibrated instrument, tuned to the rhythms of nature in a way that our technology has sadly allowed us to forget. This ability to sense land long before it could be seen was the cornerstone that enabled the settlement of the most remote islands on the planet, including the Hawaiian archipelago and Rapa Nui, also known as Easter Island. This incredible feat of settling such isolated specks of land in the vastness of the Pacific is something that modern science, for all its tools, still grapples with. The prevailing winds and currents in the Pacific generally move from east to west, which would have made sailing eastward toward islands like Hawaii or Easter Island incredibly difficult, essentially going against the flow of the ocean. How did they do it? The oral traditions hold the answer. Polynesian navigators possessed an intimate understanding of seasonal wind shifts. They knew that during certain times of the year, the predominant easterly winds would falter, creating brief windows of westerly winds that they could use to sail east. They would wait for these precise meteorological moments, these cracks in the usual weather patterns, and then launch their great voyages of colonization. They weren't just drifting, they were executing carefully timed strategic missions based on centuries of accumulated climatic data stored in their charts. This challenges the old Eurocentric idea that these were accidental discoveries made by lost fishermen. They were intentional, brilliantly planned journeys of expansion, some of the most ambitious seafaring ventures in human history, all accomplished without writing, relying solely on the resilience and accuracy of an oral code. This reliance on memory and oral tradition, as fragile as it might seem, offers a powerful counterpoint to our modern dependence on technology. In a world where we readily outsource our sense of direction to a smartphone, the Polynesian Wayfinder reminds us of the profound capabilities of the human mind. Their knowledge wasn't stored on a server that could crash or a device that could run out of battery. It was stored in a living community, constantly practiced, refined, and passed on. Its resilience is proven by its survival. Even after European contact introduced new technologies and suppressed indigenous practices, leading to a steep decline in wayfinding, the embers of this knowledge were kept alive by a few key individuals like Mau Piailug. His willingness to share this knowledge with a new generation, both within and outside of Polynesia, sparked a cultural renaissance that continues to this day. This revival is a testament to the enduring power of this wisdom, a form of understanding that transcends written records because it is not just known, it is felt, lived, and sailed. It is a code written not on paper but on the water, in the stars, and in the hearts of those who choose to listen. While the Polynesian wayfinders were charting the vast Pacific in their minds, other civilizations were beginning to leave a more permanent record of their understanding of the world, translating their knowledge onto physical objects. The earliest maps were far more than simple direction-finding tools. They were profound expressions of a culture's entire worldview, blending observable geography with deep spiritual and mythological beliefs. Imagine a Babylonian scholar, not with a precise surveyor's tool, but with a stylus in hand, pressing symbols into a soft clay tablet. The map he creates isn't meant to guide a sailor to a specific port, but to illustrate the very structure of the universe as his people understood it. This is where we find one of the most fascinating artifacts of ancient cartography, the Babylonian world map dating back to around 600 BCE. This incredible clay tablet, now housed in the British Museum, presents the Earth as a flat, circular disk floating in a vast ocean, with Babylon proudly at its center. Radiating out from this central point are strange, labeled circles representing other cities and regions, all surrounded by a ring of water labeled Bitter River. Beyond this ocean, in the corners of the tablet, lie triangular regions described as beyond the flight of birds, mysterious lands that were likely the stuff of legend and myth. This map wasn't a failure of accuracy, it was a triumph of cosmology. It wasn't designed for physical navigation but for intellectual and spiritual orientation, showing a person their place not just in a kingdom but in the entire cosmic order. It was a diagram of reality itself, a powerful blend of known geography and symbolic representation that reinforced the cultural and religious identity of the civilization that made it. This blend of the practical and the symbolic continued for centuries. In medieval Europe, a very different kind of map emerged, one that served a similar purpose of placing the viewer within a divine cosmos, the Mappa Mundi. The most famous of these, the Hereford Mappa Mundi, created around the year 1300, is a magnificent tapestry of ink on parchment, measuring over 5 feet across. Jerusalem sits at the very center of the world, reflecting its supreme importance in the Christian faith. The continents of Europe, Asia, and Africa are arranged around it, but they are populated with a wild menagerie of creatures and scenes. You can find the Garden of Eden, the Tower of Babel, and a host of mythical beasts like the Bonacon and the Cyapod. For a traveler of the time, this map was less a tool for finding a physical road and more a guide for a moral and spiritual journey, illustrating the wonders and dangers of God's creation and the path to salvation. Yet, at the very same time these magnificent theological maps were being drawn, a secretive, practical cartography was being developed by and for the people who actually braved the seas, the sailors and merchants of the Mediterranean. These were the Portolan charts, and they represent a stunning leap in practical accuracy. Originating in the 13th century, likely in Italy or Catalonia, these charts were drawn on parchment and focused exclusively on the coastline. The interior of continents are often left completely blank because for a sailor, the land was just a hazard to be avoided. The coast was everything. What makes these maps so astonishing is their precision. The coastlines of the Mediterranean and Black Sea are rendered with a detail that seems almost modern, their contours recognizable to us today. How did they achieve this without satellite imagery or advanced mathematics? The secret likely lies in the accumulated, first-hand experience of countless mariners. For generations, sailors had been keeping mental notes and rough sketches of coastlines, noting the shape of a particular headland, the depth of a bay, or the safe approach to a hidden harbor. The creators of Portolan charts, who were often themselves seasoned navigators, compiled this vast repository of lived knowledge into a single, standardized form. They used a system of room lines, a web of lines radiating from central compass roses that showed constant bearing directions. A sailor could use a pair of dividers to plot a course from one port to another by following these room lines. This wasn't abstract cartography based on mathematical projection. It was a direct translation of lived, empirical experience onto parchment. It was the written, shareable version of the Polynesian mental map, a collective intelligence made visible. The contrast between the symbolic mapper Mundi and the practical Portolan chart reveals the two powerful, often competing, impulses behind mapmaking: the desire to understand our place in a spiritual universe and the urgent need to find our way through the physical one. Both, in their own way, were crucial codes for navigating the unknown. While the Polynesians were mastering the Pacific and medieval Europeans were drawing their dual-purpose maps, another civilization was achieving something arguably even more foundational to the story of exploration. Centuries earlier, a people emerged from the narrow coastal strip of land that is modern-day Lebanon and Syria, and they would go on to become the undisputed masters of the Mediterranean Sea. The Phoenicians weren't just skilled sailors, they were the architects of the first truly international maritime trading network, a web of commerce and culture that connected the entire ancient world for over a millennium. From roughly 1500 to 300 BCE, their distinctive ships with high-curved prows and square sails were a common sight from the eastern shores of the Mediterranean all the way to the Atlantic coasts of Spain and North Africa. They didn't build a traditional empire of conquered land. They built an empire of trade routes, establishing a chain of coastal colonies and trading posts that served as safe harbors and resupply stations. Cities like Carthage in North Africa, Cadiz in Spain, and even Malta became thriving hubs of Phoenician commerce, outposts of a culture whose power was measured not in acres of territory but in control of the sea lanes. What truly set the Phoenicians apart, and what makes their story so intriguingly mysterious, was their fanatical secrecy. In an age where knowledge was often shared for the common good, the Phoenicians treated their navigational expertise like a state secret, a proprietary technology to be guarded at all costs. They understood that their wealth and power depended entirely on their ability to go where others could not, and to do so more efficiently. Their routes, their knowledge of currents and safe harbors, and their celestial techniques were not written down in manuals available to all. Instead, this priceless information was passed down orally within tight-knit families of ship captains and navigators from father to son, ensuring it never fell into the hands of their competitors. The Greek historian Strabo even tells a story of a Phoenician captain who, upon realizing he was being followed by a Roman ship eager to learn the route to Britain's valuable tin mines, deliberately ran his own vessel aground on a sandbank to protect the secret, knowing his government would reimburse him for the loss. This anecdote, whether entirely true or not, captures the extreme lengths to which they would go to protect their commercial advantage. Their maps, if they even created any beyond simple coastal sketches, were likely considered such vital secrets that they were never widely distributed, and none have survived. So, without written records, how can we possibly know how they navigated? We have to piece it together from accounts by their rivals and from logical deduction. The Greeks, who were both their trading partners and their competitors, recorded that the Phoenicians were expert celestial navigators. They undoubtedly used the North Star, which they knew as the Phoenician Star, to hold a steady course north or south. During the day, they almost certainly used a form of dead reckoning, estimating their speed and direction to plot their position. They may have also used the gnomon, a simple vertical rod that casts a shadow. By measuring the length and direction of the sun's shadow at its highest point, a skilled navigator could estimate both the time of day and their latitude. But perhaps the most tantalizing clue to their advanced skills comes from a voyage mentioned by the Greek historian Herodotus. He writes that around 600 BCE, the Egyptian pharaoh Necho-Roman II commissioned a team of Phoenician sailors to attempt a truly audacious feat, to circumnavigate the continent of Africa. According to the account, they set sail from the Red Sea, heading south. They rounded the Cape of Good Hope, sailed up the western coast of Africa, and returned to Egypt through the Strait of Gibraltar 3 years later. Most astonishingly, Herodotus notes that during the voyage, the sailors reported that at one point the sun was on their right-hand side, to the north. This is a detail that would have been inexplicable to a Greek familiar only with the northern hemisphere, but it is precisely what one would experience when sailing around the southern tip of Africa. This single, seemingly offhand observation lends a powerful credibility to the story and suggests the Phoenicians ventured far beyond the Pillars of Hercules, the gateway to the Atlantic Ocean, exploring the western coasts of Africa and Europe. And then, almost as suddenly as they rose to prominence, their influence began to wane. They were gradually overshadowed by the rising powers of Greece and later Rome, who learned from their techniques and eventually conquered their key cities, most notably with the utter destruction of Carthage in 146 CE. With their decline, their tightly held secrets began to vanish. The family lineages of navigators were broken, their unique knowledge dispersed and forgotten. The Romans were brilliant engineers and administrators, but they were not the same kind of intuitive, star-reading mariners. They preferred to sail close to shore and relied on the established routes the Phoenicians had pioneered without necessarily understanding the deeper celestial science behind them. This loss represents one of the great gaps in our understanding of ancient exploration. We are left with fragments, accounts from their rivals, the archaeological remains of their ships and trade goods, and the indelible mark they left on place names and culture across the Mediterranean. But the core of their navigational genius, the detailed star charts, the understanding of Atlantic currents, the full extent of their discoveries, died with them. Their legacy is a powerful reminder that knowledge, even the most advanced and valuable kind, is fragile. It can be lost to conquest, to cultural change, or simply to a failure to pass it on, leaving us to wonder just how much of the ancient world's understanding of the oceans sank beneath the waves alongside the last Phoenician galley. While the Phoenicians guarded their secrets in the warm Mediterranean, another culture was solving an entirely different navigational puzzle in the harsh, often sunless North Atlantic. The Vikings, those legendary seafarers from Scandinavia, faced a unique challenge. How do you find your way when the sky is a featureless blanket of gray cloud for days on end, and the sun, your primary guide, is completely hidden? The answer, according to their ancient sagas, might lie in a seemingly magical tool, the Sunstone. These texts speak of a solarstein, a crystal that could reveal the sun's position even when it was completely obscured by cloud or fog. For centuries, this was dismissed as pure myth, a fantastical element of storytelling. But modern science has performed a stunning reversal, suggesting the Vikings might have been using a form of technology we are only now beginning to appreciate. The leading theory points to a specific type of crystal known as Iceland spar, a transparent form of calcite that is naturally found in Scandinavia. This crystal has a remarkable property called birefringence, or double refraction. When light passes through it, it splits into two separate beams. Crucially, sunlight becomes polarized, meaning its light waves vibrate in a specific direction as it passes through the Earth's atmosphere. An Iceland spar crystal can filter this polarized light. A skilled navigator could hold the stone up to the sky and slowly rotate it. When the light passing through the crystal appears to be of equal intensity, or when the two images seen through it merge into one, the crystal is aligned with the direction of the polarized light from the hidden sun, thereby revealing its position. It's a sophisticated concept, one that feels almost like a precursor to optical physics. In 2011, a team of researchers published a study demonstrating that this method is not only theoretically sound but also highly accurate, potentially allowing a navigator to pinpoint the sun's location within a few degrees even under thick cloud cover. The mythical sunstone, it turns out, has a solid foundation in scientific reality. But a sunstone alone isn't enough to cross an ocean. You also need a way to consistently track your direction and latitude. This is where other Viking tools come into play. Archaeologists and historians believe they used a simple but effective device known as a sun compass. This was likely a wooden disc with a central gnomon or pin that would cast a shadow. The disc would be marked with a series of lines indicating the direction of the shadow at different times of the day, and most importantly, at different times of the year. The path of the sun's shadow changes with the seasons. It's much longer in the winter than in the summer. A navigator would have had a set of these calibrated discs, choosing the one appropriate for the time of year of their voyage. By aligning the compass so the shadow fell on the correct line, they could maintain a steady course east or west. A fragment of such a disc, dated to around the year 1000, was actually discovered at a Viking site in Greenland, bearing precisely these kinds of markings. It's a tangible link to their practical methods, for voyages north to south crucial for finding the latitude of their destination. They may have used another tool mentioned in the sagas, the horizon board. This was a simple board with a series of holes and a movable peg. The idea was to measure the sun's altitude, its height above the horizon at its highest point at noon. By comparing this measurement to the known altitude at a specific location, like their home port, a navigator could tell if they were sailing too far north or south. It was a primitive form of latitude sailing, but combined with the sun compass for east-west direction, it created a surprisingly robust navigational system. This toolkit, the sunstone for cloudy days, the sun compass for direction, and the horizon board for latitude, paints a picture of Viking navigation that was anything but primitive guesswork. It was a systematic, technologically aided practice. This technological prowess is what enabled their staggering voyages. Using these tools, combined with their innate mastery of the sea itself, they undertook journeys that would daunt modern sailors. They settled Iceland in the late 9th century, a voyage of over 600 miles from Norway across often stormy seas. From there, they pushed further west, discovering and colonizing Greenland in the 10th century, a journey of another 1,000 miles into the icy waters of the North Atlantic. And most famously, around the year 1000, Leif Erikson led an expedition that reached the coast of North America, a place they called Vinland, nearly 500 years before Christopher Columbus was even born. These were not accidental landfalls made by ships blown off course. They were deliberate acts of exploration and colonization, repeated successfully over generations. They required the ability to not only find these new lands once, but to return to them reliably, to establish trade routes between Greenland, Iceland, and Scandinavia. This would have been utterly impossible without a reliable and repeatable method of navigation. The Vikings were also, like the Polynesians, master naturalists. Their tools were augmented by a deep reading of the environment. They watched for specific species of birds, knowing that puffins and guillemots could only be found within a certain distance from land. They learned to interpret the patterns of ocean swells and the direction of the prevailing winds. They observed the migration patterns of whales. They even learned to spot the telltale reflection of ice fields on low clouds, a phenomenon known as ice blink, which could warn them of dangerous icebergs or guide them toward the frozen coasts of Greenland. Their success was a fusion of technology and tradition, of cutting-edge crystal optics and ancient, accumulated environmental wisdom. The existence of the sunstone challenges our long-held assumption that medieval technology was simple and unsophisticated. It suggests that the Vikings possessed a hidden scientific understanding that allowed them to conquer the North Atlantic in a way that no other European culture could for centuries. They weren't just fierce warriors, they were some of the most innovative and capable navigators the world has ever seen, their legacy written not in sagas of myth, but in the very real currents of the ocean they mastered. But if we shift our perspective from the Vikings' practical tools to the maps they and others might have used, we uncover a completely different dimension of ancient navigation, one where geography was inseparable from belief, and a map was less a tool for travel and more a guide to the soul. For many early civilizations, the world was a place brimming with meaning, where every mountain, river, and stretch of ocean held not just physical properties but spiritual significance. A map, therefore, was not merely a representation of space, it was a diagram of reality itself, a canvas onto which they painted their deepest fears, highest hopes, and most profound understanding of the cosmos. To view these artifacts through a modern, purely utilitarian lens is to miss their entire purpose. They were theological statements, moral compasses, and encyclopedias of cultural knowledge, all rolled into one. Take the Hereford Mappa Mundi, created around the year 1300. At first glance, it appears chaotic, even nonsensical to a modern eye accustomed to the clean lines of Google Maps. Jerusalem sits proudly at the very center of the world, not because it was the geographical midpoint of any known trade route, but because it was the spiritual center of the Christian universe, the site of Christ's crucifixion and resurrection. The continents are arranged around it in a circular pattern, with east the direction of the Garden of Eden placed at the top. This orientation alone tells us that the map's primary function was not to get a traveler from London to Rome, but to orient a faithful Christian within God's creation. The map is populated with hundreds of intricate drawings, biblical scenes like Noah's Ark, mythical creatures like the Cyapod's men with a single giant foot they used for shade, and the monstrous races said to inhabit the edges of the known world. These weren't included as mere decoration or because the cartographer was ignorant. They were placed there with intention. A sea serpent coiled in the ocean wasn't just a fanciful illustration. It was a symbol of the very real and terrifying dangers that lurked in the unknown, both physical and spiritual. The map served as a visual sermon, teaching the viewer about the wonders and perils of God's world, and reinforcing the centrality of the Christian faith in understanding it all. This blending of the physical and spiritual was a universal language in mapmaking. Long before the Hereford Mappa Mundi, the ancient Babylonians created their own world map on a clay tablet, showing the earth as a flat disk floating in a bitter river, with Babylon itself at its center. The areas beyond were not blank spaces awaiting discovery. They were intentionally marked as mysterious, dangerous lands where the sun is not seen. For the Babylonians, the map defined their world order, placing their kingdom at the heart of a cosmos they understood and relegating everything else to the realm of chaos. Similarly, many Islamic maps from the same medieval period placed the sacred city of Mecca at their center, while Chinese maps often reflected the Confucian worldview of the Middle Kingdom as the civilized center of the world, surrounded by less culturally refined tributary states. In every case, the map was a powerful tool of identity, telling the people who made it exactly who they were and where they stood in the grand hierarchy of creation. So, what was the practical use of such a map for an actual traveler? While a medieval merchant might not have used the Hereford Mappa Mundi to navigate the Alps, he would have understood its symbols. Seeing a depiction of a dragon in a certain region on a map would have communicated real, practical information. This is a place to be wary of, whether due to bandits, dangerous wildlife, or difficult terrain. The map acted as a cultural and moral guidebook. A pilgrim traveling to Jerusalem would be fortified by seeing his destination glorified at the center of the world. His long and perilous journey was given deeper meaning, transformed from a simple trek into a spiritual quest. The maps provided a framework for understanding the experiences of travel. A storm at sea wasn't just bad weather. It was a confrontation with the symbolic sea monsters depicted on the chart, a trial of faith and courage. This symbolic layer provided a psychological roadmap, helping travelers process the fear and disorientation of venturing into the unknown by framing it within a familiar story of divine order and moral testing. To truly decipher these ancient maps, we must learn to read them as their creators intended, not as failed attempts at scientific accuracy, but as profound and sophisticated codes that mapped the human experience itself, charting a course through both the visible world and the invisible realms of belief. Think of the ocean not as a blank, empty expanse, but as a bustling network of liquid highways, each with its own distinct flow, speed, and character. For ancient mariners, these currents were not obstacles to be overcome. They were powerful allies to be understood and embraced. They realized that by aligning their voyages with these massive, moving rivers within the sea, they could dramatically increase their speed, conserve precious energy, and extend their range far beyond what muscle power alone could achieve. This was the art of sailing with the environment, not against it, a philosophy that turned the seemingly chaotic ocean into a predictable and manageable system. The Polynesian voyagers, for example, didn't just know that a current existed, they knew its precise behavior. They understood how the great equatorial currents would carry them westward, and they had an intimate knowledge of the countercurrents that flowed in the opposite direction, allowing them to make their return journeys eastward. This wasn't a vague notion. It was a precise science of motion, memorized through generations of observation and encoded into their oral chants. A master navigator would feel the specific temperature and texture of a current against the hull of his canoe, recognizing it as surely as a modern commuter recognizes a familiar exit on a freeway. He knew that entering a particular current at a specific point would deliver him, hours or days later, to the precise approach of a target island. This mastery transformed the vast Pacific from an impenetrable barrier into a connected web of pathways, a maritime interstate system that enabled the greatest migration in human history. This deep environmental intelligence extended from the water below to the air above. While currents provided the push, the wind provided the power, and ancient cultures became master meteorologists, decoding the planet's grand atmospheric patterns. Perhaps no one harnessed the wind more spectacularly than the Arab and Indian traders of the Indian Ocean. They didn't merely wait for favorable winds, they built their entire annual trading calendar around the monsoon seasons. These are not simple storms, but a colossal seasonal reversal of wind patterns. For roughly 6 months of the year, the winds blow steadily from the northeast, and for the other 6, they reverse and blow with equal force from the southwest. This predictable clockwork rhythm allowed for astonishingly efficient trade. A merchant in Oman could load his dhow with goods, catch the northeast monsoon to the coast of India, sell his cargo, and then wait for the winds to reverse. When the southwest monsoon began, he would load up with new goods from India and let those reliable winds carry him all the way back home. This wasn't just convenient, it was the engine of a massive economic network that connected East Africa, the Arabian Peninsula, India, and Southeast Asia for centuries. Their knowledge was so precise that they could predict the monsoon's arrival within a window of just a few days, allowing them to plan voyages with a reliability that would be the envy of any modern shipping logistician. They read the subtle signs in the sky and the sea, the build-up of certain cloud types, a change in the humidity, the behavior of wildlife, to know exactly when the great wind shift was imminent. What's truly humbling is that this ancient empirical knowledge is now being validated by our most advanced scientific instruments. Modern oceanographers mapping the Gulf Stream with satellite altimetry find that its core path and speed are exactly where and what centuries of sailor logs described. Climate scientists studying the monsoon patterns confirm the incredible regularity and power that Arab traders depended upon. These early navigators had, through pure observation and accumulated experience, built a working model of planetary-scale systems. They understood the interconnectedness of the ocean and the atmosphere in a way that was profoundly holistic. A Polynesian navigator feeling a shift in wind direction would immediately know how that would alter the swell patterns hours later. An Arab sailor noticing a change in water temperature would anticipate a shift in the wind. Theirs was a dynamic, real-time navigation that synthesized countless environmental inputs. This stands in stark contrast to our modern, often siloed, approach to travel. We turn on GPS and follow a straight line on a screen, largely oblivious to the powerful natural forces flowing beneath and around us. We fight against headwinds and currents that ancient mariners would have simply avoided or used to their advantage. Theirs was a dance with nature, a partnership built on respect and deep understanding. In an age of climate change, where we are increasingly aware of our disruptive impact on these very systems, their example is more relevant than ever. They remind us that true mastery lies not in dominating the natural world, but in learning to listen to its rhythms and moving in harmony with them. This intimate connection with the living world extended far beyond reading the waves or the stars. It involved a silent partnership with the animals that shared the ocean. For these ancient wayfinders, the sea and sky were not empty voids but bustling communities, and every creature within them could become a vital signpost pointing the way home. This practice of bionavigation required a level of observation so refined that it bordered on a sixth sense, an ability to interpret the subtle language of wildlife that we have largely forgotten in our age of digital beacons and satellite pings. Consider the humble seabird, perhaps the most reliable natural guide for a sailor lost in a featureless blue desert. Different species have vastly different ranges and behaviors, and ancient navigators knew these distinctions with encyclopedic precision. The Polynesians, for instance, paid close attention to the manu oku, or white tern. This beautiful, ghostly white bird is a crucial indicator because while it flies far out to sea to fish, it cannot land on the water. It must return to its nest on dry land every single night. Spotting these birds in the evening, and more importantly, noting the direction of their flight, was like seeing an arrow pointing directly to an island that was still dozens of miles beyond the horizon, completely invisible to the human eye. Similarly, the golden plover was known to migrate between Tahiti and Hawaii. By observing its flight path, a navigator could effectively hitch a mental ride, trusting the bird's innate compass to lead them to land. This wasn't a casual guess. It was a calculated strategy based on generations of meticulous ornithological study, passed down through chants and stories. This wisdom was not confined to the warm Pacific. Far away in the cold, foggy waters of the North Atlantic, Norse sailors developed their own relationships with the local fauna. They learned to watch for whales not with fear but with anticipation. Certain species, like the pilot whale, were known to frequent specific feeding grounds along regular migration routes. A pod of whales surfacing near the ship could indicate that land was near or that the sailors were on a known, productive pathway. The presence of particular seabirds was equally telling. A sailor would know that the northern gannet, with its 6-foot wingspan, rarely ventured more than 100 miles from land. Spotting one was a heartening sign. Even the sight of seaweed floating in the water or a specific type of land-based insect blown out to sea could provide a crucial clue, hinting at a shoreline upcurrent. These weren't just random observations, they were pieces of a puzzle, each one helping to confirm or adjust the ship's estimated position on the navigator's mental chart. The most astonishing aspect of this holistic method is that it often involved interpreting negative evidence. The absence of a sign could be just as telling as its presence. A skilled navigator would notice when the usual deep ocean birds began to disappear, replaced by species that stayed closer to shore. The character of the ocean itself would change. The watercolor might shift from the deep indigo of the abyssal plain to the greener hue of a continental shelf. The very smell of the air could carry the scent of land, the fragrance of flowers, the smoke of a distant fire, or the distinct smell of mud from a river delta, long before any land was visible. This multi-sensory approach created a layered and redundant navigation system. If the stars were hidden by clouds, they could read the waves. If the waves were calm, they could watch the birds. If no birds were present, they could smell the wind or feel a change in the swell. They had built a fail-safe network of environmental clues, ensuring they were never truly lost as long as they remained attentive to the world around them. This profound integration with their ecosystem stands in stark contrast to our modern relationship with navigation, which often involves staring at a glowing screen, isolated from the very environment we are traveling through. We trade intuitive understanding for pinpoint accuracy, gaining incredible convenience but losing that deep, silent conversation with the natural world that guided our ancestors across the planet. Now, let's turn our attention to one of the most tantalizing and hotly debated artifacts in the entire history of cartography, a map that seems to defy its own time, a document that has sparked theories of lost civilizations, forgotten explorers, and even ancient advanced technologies. This is the Piri Reis map, a stunningly detailed and perplexing chart drawn on gazelle skin by the Ottoman admiral and cartographer Piri Reis in the year 1513. At first glance, it is a beautiful example of early 16th century mapmaking, blending the known world of the Mediterranean with the newly discovered coasts of the Americas. But look closer, and you begin to see the anomalies that have kept historians and conspiracy theorists awake at night for decades. The map accurately depicts the eastern coast of South America, the bulge of Brazil, and even the Amazon River, with a precision that was remarkable for its time. But it's the southern portion of the map that drops the real mystery. Stretching off from the southern tip of South America is a landmass, a coastline that appears to show what we now know as Antarctica. But Antarctica wasn't officially discovered until 1820, over 300 years later. Even more baffling, this depicted coastline seems to show the continent not as it appears today, buried under miles of ice, but as it might have looked thousands of years ago during a period when its shores were ice-free. How could an Ottoman admiral in the early 1500s have possibly known this? The most popular and sensational theory suggests that the map incorporates fragments of far older knowledge, passed down from a highly advanced ancient civilization, perhaps even the mythical Atlantis, that mapped the world with a sophistication that was later lost to history. Other, even more fringe ideas propose that such precise geographical data could only have come from an aerial or orbital perspective, hinting at extraterrestrial intervention. These are thrilling narratives straight out of an adventure novel, but the more grounded, scholarly explanation is perhaps just as fascinating. Piri Reis himself wrote notes on the map, stating that he had compiled it from numerous source maps, including about 20 from the time of Alexander the Great, and most intriguingly, from a map used by Christopher Columbus. This admission is the key that most historians use to unlock the mystery. The map is likely a composite, a masterpiece of compilation from countless sailor logs, Portuguese and Spanish Portolan charts, and the oral reports of mariners who had actually sailed these new routes. The accurate depiction of South America makes perfect sense in this context. By 1513, the Portuguese had been charting the Brazilian coast for over a decade. The strange southern landmass could then be explained as a composite error, a misinterpretation of reports about the southern tip of South America, combined with speculation about a great southern continent that had been a part of European geographical lore since the time of the ancient Greeks. But the Antarctica problem persists. In the 1950s, the map was examined by Arlington Mallory, an engineer who claimed the projection used was so advanced that it must have been based on aerial surveys. Later, Professor Charles Hapgood, in his book, Maps of the Ancient Sea Kings, argued that the map showed Antarctica's Queen Maud land with accurate details of its subglacial topography, details that were only confirmed by modern seismic surveys in the 1950s. Hapgood's theory was that a prehistoric seafaring civilization had accurately mapped the globe before the last ice age, and that fragments of their knowledge survived, eventually finding their way into the libraries of Constantinople and into the hands of Piri Reis. While mainstream geology largely dismisses the idea of a recent, ice-free Antarctica, the puzzle remains a powerful lure. The map forces us to confront the gaps in our historical record. How much knowledge was truly lost when the Library of Alexandria burned? How many voyages of discovery were never recorded, their details only surviving as half-remembered tales in sailors' taverns? The Piri Reis map is less a definitive answer and more a profound question mark etched in ink and parchment. It challenges the linear narrative of human progress, suggesting that the past might be far more complex and far more intelligent than we have ever given it credit for. It stands as a permanent reminder that history is not a closed book, but a vast ocean, and we have only just begun to explore its depths. While the ability to read the stars and waves was a profound art, it was an art built upon a hidden foundation of sophisticated mathematics. This wasn't just observational knowledge, it was a structured, codified system of geometry and proportional reasoning that transformed the natural world into a quantifiable, predictable map. The most elegant example of this is found not in a written equation, but in the mind of a Polynesian wayfinder. Their legendary star compass wasn't a physical object you could hold. It was a complex mental construct that imposed a precise mathematical grid upon the entire celestial dome. They divided the 360-degree circle of the horizon into 32 distinct houses, or directional points. Each of these points was not just a vague direction like northwest, but was permanently anchored to the rising and setting position of a specific, named star. This created a fixed, repeating celestial clockwork. As one guiding star would rise too high or set, the navigator would simply transfer their bearing to the next star that was rising in the adjacent house, maintaining their course with mathematical consistency through the night. This system required an incredible grasp of spherical geometry, understanding how these points existed on the curved surface of an imaginary sphere surrounding the Voyager. Their entire navigational methodology was an application of dead reckoning, a continuous process of estimating their position based on speed, time, and direction, all calculated mentally without a single written number. The precision of their long-distance voyages across the Pacific stands as undeniable proof that they were not just poets of the sea, but also brilliant, intuitive mathematicians. On the other side of the world, in the bustling intellectual centers of the Islamic Golden Age, this mathematical coding was made manifest in breathtakingly intricate instruments. Here, navigation was explicitly married to the rigorous science of trigonometry. Scholars and astronomers developed devices like the astrolabe and the quadrant, which were essentially analog computers crafted from brass and wood. An astrolabe was a complex handheld device, a star chart and a calculator combined into one. By aligning its movable parts with a specific star, a navigator could solve trigonometric problems to determine the time, their latitude, and even the direction to Mecca for prayer. It worked by projecting the three-dimensional sky onto a two-dimensional plate, a concept based on precise mathematical projection. The mariner's quadrant was simpler but no less brilliant. By measuring the angle between the horizon and a celestial body like the North Star or the Sun at its highest point, a sailor could calculate their latitude. This required understanding that this angle, known as altitude, increased predictably as you sailed north from the equator and decreased as you sailed south. Using pre-calculated trigonometry tables that were developed in observatories from Baghdad to Andalusia, they could convert this measured angle into a geographical position. These weren't mere tools, they were the physical embodiment of mathematical laws, allowing sailors to quantify their place on the Earth with a degree of accuracy that was previously unimaginable. What's truly fascinating is how these mathematical codes were often concealed within the fabric of culture, embedded in rituals, artifacts, and artistic designs rather than in formal textbooks. The geometry of a Polynesian star compass was passed down through chants and dances, its numerical precision preserved in rhythm and rhyme. The complex gnomons and shadow scales used by ancient Egyptians and Chinese to track the sun's path were often incorporated into ceremonial architecture, like obelisks and temples, blurring the line between practical science and spiritual practice. The layout of certain ancient cities and megalithic structures shows alignments with key solar and lunar events, suggesting a widespread, implicit understanding of astronomy for calendrical and directional purposes. This integration reveals that for these cultures, mathematics was not an abstract discipline separate from everyday life. It was the hidden language of the universe, a code that could be used to navigate both the physical and the metaphysical world. Their innovations, from the mental geometry of the Pacific to the brass trigonometry of the Mediterranean, were not just clever tricks. They were the foundational steps that laid the groundwork for the entire scientific revolution, proving that the desire to measure, calculate, and understand our place in the cosmos is a deeply human impulse that has been guiding us long before the invention of the first calculator. This living library of knowledge, carried in memory and passed from mentor to apprentice through song and story, was both the great strength and the profound vulnerability of ancient navigation. Unlike a book that could be shelved and rediscovered centuries later, this wisdom resided in people. It was a flame that needed constant tending, and when those human repositories were extinguished through tragedy, upheaval, or simply the passing of an elder without a student, the light could go out in an instant. The primary engine of this transmission was the master-apprentice relationship, a years-long immersive experience where a young navigator didn't just learn facts but absorbed an entire worldview. He would spend countless hours memorizing star paths through chants whose rhythms mirrored the ocean's swell, learning to feel the subtle shift of currents through the hull of a canoe, and internalizing the seasonal behaviors of birds and fish. This knowledge was encoded in every aspect of culture, from the dances that told stories of great voyages to the rituals performed before a launch. It was a holistic education that wove together practical skill, spiritual belief, and communal identity into a single, unbreakable cord, or so it seemed. The arrival of European explorers and colonizers in the Pacific from the 18th century onward placed this entire system under catastrophic pressure. The introduction of new technologies like the magnetic compass, sextant, and eventually charts was just one part of the story. While these tools were seductively convenient, The true blow was the deliberate and often violent suppression of indigenous cultures, languages, and practices. Colonial authorities, missionaries, and new economic systems viewed traditional wayfinding not as a sophisticated science but as primitive superstition. The great double-hulled voyaging canoes, the very vehicles of exploration, were replaced by Western ships or left to rot on shore as island economies were redirected toward plantation labor and trade with the outside world. The young men who would have trained for years to become master navigators were now in school learning a different history or working for wages in a foreign system. The chants were forgotten, the stars grew dim in collective memory, and within just a few generations, the once unbroken chain of knowledge that had settled the largest ocean on Earth was severed. The Pacific, which had been a connected highway of culture for millennia, became a barrier between isolated islands, its ancient pathways erased from human consciousness. This loss wasn't a natural fading, it was a direct consequence of cultural disruption, a demonstration of how fragile a purely oral tradition can be when confronted with a powerful, literate, and expansionist world. Yet the most inspiring chapter in this story is one of breathtaking recovery. The embers of this knowledge, though scattered, were not entirely cold. In the 1970s, a movement emerged driven by a deep cultural yearning to reclaim this lost identity. The project was the Hokulea, a full-scale replica of a traditional Polynesian voyaging canoe. Its goal was audacious, to sail from Hawaii to Tahiti using only the ancient methods, proving that the voyages described in oral histories were not myths but achievable feats of skill and courage. The challenge, of course, was that no one in Hawaii remembered how to do it. This is where the last living masters from the few pockets where fragments of knowledge had survived became crucial. The legendary Micronesian navigator Maupiailug from the small island of Satawal agreed to share his sacred knowledge. He was one of the last few people on Earth who still practiced the full art of non-instrument wayfinding. In 1976, he guided the Hokulea on its historic journey, a voyage that stunned the world and reignited a cultural revolution across Polynesia. The success of the Hokulea was more than just a spectacular adventure. It was a powerful act of cultural rediscovery. It proved that the codes could be deciphered, that the star paths could be relearned. Most importantly, it inspired a new generation to seek out the remaining elders, to study the old chants with new purpose, and to rebuild the apprentice system. Today, the Hokulea and other canoes in its wake have undertaken voyages around the globe, their crews trained in the old ways. This revival is a living testament to the resilience of human knowledge. It shows that even when a tradition appears to be lost, its echo can persist, waiting for the right moment and the right people to listen closely and bring it back to life. This cycle of loss and recovery is a humbling lesson for all of us. It underscores that our collective human heritage is a vast and delicate tapestry, and every thread, every song, every story, every technique is precious. Preserving this diversity of knowledge isn't just about honoring the past. It is about safeguarding a vast library of human ingenuity, ensuring that future generations have a full toolkit of wisdom, both ancient and modern, to navigate the challenges that lie ahead. While the Polynesians were reading the waves and the Vikings were deciphering sunstones, a completely different set of navigational challenges was being solved in the world's most extreme landscapes. The methods that emerged in these harsh environments were not just variations on a theme. They were entirely unique codes forged by necessity and refined through generations of intimate contact with a specific place. This profound adaptation to local geography and climate stands as a powerful testament to human ingenuity. proving that there is no single right way to navigate, only the way that works for the land and the sky you call home. Consider the vast, rolling seas of sand that define the deserts of the Arabian Peninsula and North Africa. For the Bedouin people, the desert was not a barren wasteland but a familiar homeland, and navigating its featureless expanses required a skill set utterly different from that of an ocean voyager. Without distinct landmarks or a visible horizon, they became masters of micro-observation. They learned to read the stars with a precision that put them on par with any Polynesian navigator, using constellations not just for direction but also for telling time at night, crucial for planning the cool hours of travel. But their true genius lay in reading the desert itself. They could navigate by the shape and texture of sand dunes, knowing that the windward side of a dune was typically gentler and the leeward side steeper. The direction of the prevailing wind would sculpt the dunes into consistent patterns, turning what looked like chaos to an outsider into a clear directional marker. They observed the color and composition of the sand, which could change subtly from one region to another, and even the types of rocks scattered across the ground. The sparse vegetation also held clues. Certain hardy plants would grow in a specific orientation to the sun or wind. A Bedouin navigator could literally feel their way across the desert, their knowledge so deeply ingrained that it felt like a sixth sense, a living map written in the sand and the stars. Now travel from the scorching, sun-baked dunes to the opposite extreme, the frozen, monochromatic world of the Arctic. For the Inuit and other indigenous peoples of the far north, the challenges were inverted. The sun could disappear for months during the polar night, and the landscape was a constantly shifting canvas of ice and snow. Here, celestial navigation was often useless for long stretches of the year. Instead, Inuit hunters developed an astonishing ability to read the ice and the wind. They could discern safe ice from thin, dangerous ice by its color and texture, a skill that was literally a matter of life and death. They learned to interpret snowdrifts, which are sculpted by the prevailing winds. The shape, hardness, and direction of a drift could tell a traveler which way the wind had been blowing, providing a reliable compass even in a whiteout. They paid close attention to the direction of sastrugi, those hard, wave-like ridges of snow carved by the wind, which could serve as highway markers across the tundra. And just as Polynesians read ocean swells, Inuit would observe the pressure ridges in the sea ice, massive upheavals caused by colliding flows, using their complex patterns as a map of the frozen seascape. They also watched the behavior of wildlife. The migration paths of caribou or the direction a polar bear was walking could offer hints about the location of open water or stable ice. Their navigation was a continuous, multi-sensory dialogue with a world that appeared static and empty to outsiders but was, in reality, teeming with information. This incredible diversity of method from desert to ice, from ocean to jungle, reveals a universal truth about human innovation. Faced with the problem of not getting lost, we don't invent a single solution. We look around us and decode the specific language of our environment. The Bedouin had no need to learn about ice patterns, just as the Inuit had no need to memorize the shapes of sand dunes. Each culture developed a hyper-specialized body of knowledge, a unique code that was perfectly tailored to its ecological niche. This deep, localized intimacy is what made these systems so brilliantly effective. A master navigator from one environment would be completely lost in another, not through any lack of intelligence, but because the very language of the land was different. This specialization was our greatest strength for millennia, allowing us to thrive in every corner of the globe. Yet, this deep specialization also contains a note of poignancy, for it highlights the fragility of such knowledge. These intricate codes, honed over centuries, are not easily transferred. When climates change rapidly, or when new technologies displace traditional ways of life, this hard-won wisdom can become obsolete in a frighteningly short time. The ice that the Inuit learned to read is now melting at an unprecedented rate, altering the very landscape that their navigation system is based upon. The desert regions navigated by the Bedouin are expanding and changing due to climate change and modernization, while younger generations, armed with smartphones and GPS, often see little need to learn the old stars and sand methods. This is the double-edged sword of progress. While modern technology offers incredible safety and convenience, it also risks severing our direct sensory connection to the natural world. The story of these environmental navigators reminds us that every ecosystem holds its own unique wisdom, a library of knowledge built from thousands of years of observation. Losing these specialized codes doesn't just mean forgetting an old way of travel. It means closing a book on a unique human understanding of the planet, a chapter of intimacy with the Earth that we may desperately need to reopen in the uncertain future ahead. While the oral traditions and star paths give us a window into the minds of ancient navigators, it is the physical objects they left behind, the shipwrecks, tools, and cargoes preserved on the seafloor, that provide the incontrovertible proof of their incredible journeys. These archaeological treasures are the hard evidence, the time capsules that allow us to touch the past and verify the stories told in sagas and chants. Perhaps no single discovery has done more to illuminate the Bronze Age world than the Uluburan shipwreck, discovered off the coast of Turkey in 1982. This wasn't just an old boat, it was a preserved moment in time, a global trading network frozen on the seabed. The ship was a Canaanite or Cypriot vessel dating back to the late 14th century BCE, and its cargo was a breathtaking inventory of the ancient Mediterranean elite. There were 10 tons of copper ingots from Cyprus, shaped like ox hides, alongside a ton of tin, likely from Afghanistan, the raw materials for bronze that powered the age. There was Egyptian gold, African ebony, amber from the Baltic, and even a golden scarab inscribed with the name of Nefertiti. This one shipwreck proves that 3,400 years ago, traders were undertaking voyages of staggering complexity, connecting empires and continents in a web of commerce that required sophisticated navigation to sustain. Among the wreckage, archaeologists also found the navigators' tools, stone anchors used to hold the ship steady in unfamiliar harbors, and wooden writing tablets that may have held the ship's manifest or even navigational notes. The Uluburan ship is a powerful reminder that these were not mythic journeys but real, dangerous, and highly profitable enterprises, all conducted without maps as we know them, relying on the kind of celestial and environmental wisdom we've been exploring. But if the Uluburan wreck shows us the what of ancient trade, another discovery hints at the astonishing how. In 1901, sponge divers off the coast of the Greek island of Antikythera stumbled upon another shipwreck, this one from the 1st century BCE. Its cargo was a collection of magnificent Greek statues, but the most significant find was a lump of corroded bronze and wood that seemed utterly out of place. For decades, it was a curiosity, but advanced imaging technology in recent years has revealed it to be one of the most sophisticated mechanical devices ever discovered from the ancient world, the Antikythera mechanism. This intricate assembly of precisely cut bronze gears, housed in a wooden case, has been called the world's first analog computer. Researchers have determined that it was a complex astronomical calculator, operated by a hand crank, that could predict the movements of the sun, moon, and planets, and even forecast eclipses years in advance. It displayed this information on dials and scales, showing the positions of celestial bodies and the timing of major athletic games like the Olympics. For a navigator, such a device would have been nothing short of revolutionary. While we have no direct evidence it was used at sea, its very existence shatters our perception of ancient technological capabilities. Imagine a ship's captain being able to consult a portable device that could tell him the precise phase of the moon or predict an upcoming eclipse, events that held both practical and religious significance. It suggests that the Greek understanding of astronomy and mechanics was far more advanced than we ever imagined, and that the tools available to some ancient mariners may have been far more sophisticated than simple stars and waves. These two wrecks represent two sides of the same coin. One reveals the sprawling economic network that demanded accurate navigation, and the other hints at the advanced intellectual tools that may have made it possible. But for every Uluburan or Antikythera, there are thousands of smaller, quieter finds that each add another piece to the puzzle. The discovery of ancient stone navigation markers on islands across the Pacific, aligned with specific stars, gives physical form to the Polynesian star compass. The unearthing of Viking sun compasses and bearing dials in archaeological sites confirms the descriptions in the sagas. Even something as simple as the distribution of distinct pottery styles or stone tools across vast distances provides a silent map of ancient sea routes. A piece of obsidian found hundreds of miles from its volcanic source is a testament to a voyage that happened. These artifacts are the silent witnesses to countless journeys whose stories were never written down. They complement the oral traditions and historical texts, grounding them in physical reality. A chant about the star that leads to Tahiti becomes infinitely more powerful when we find a stone temple on a remote atoll that is aligned with that very star. Each artifact, from the grandest mechanism to the humblest pottery shard, is a crucial data point in our effort to reverse engineer the lost codes of ancient navigation. They allow us to move beyond speculation and begin to reconstruct with growing confidence the precise and brilliant methods that allowed humanity to conquer the oceans. Imagine for a moment that you've just discovered the most valuable secret in the world, a shortcut to unimaginable wealth and power. Would you share it with everyone, or would you guard it with your life, ensuring that you and your allies alone could reap the rewards? For the great maritime empires and merchant states of history, this wasn't a philosophical question. It was the foundation of their entire economic strategy. The most accurate maps and the most efficient navigational routes were not tools for the common good. They were state secrets, more fiercely protected than any treasure chest, because they were the very keys to the treasury itself. In the high-stakes game of global trade, knowledge wasn't just power, it was profit, and it was protected with a ruthlessness that ultimately led to the loss of some of history's greatest navigational wisdom. Consider the Portuguese Empire during the Age of Discovery. In the 15th and 16th centuries, they pioneered a revolutionary sailing technique known as the volta do mar, or turn of the sea. This was a counterintuitive but brilliant maneuver. Instead of fighting against the prevailing winds and currents along the West African coast, Portuguese captains would sail far out into the Atlantic, catching the westerly winds that would carry them in a wide, sweeping arc back toward their destination. This technique allowed them to navigate the open ocean with far greater efficiency and safety, and it was the secret behind their successful voyages to India and the Spice Islands. The value of this knowledge was incalculable. Spices like pepper, cinnamon, and cloves were worth their weight in gold in European markets, and the Portuguese crown was determined to maintain a total monopoly. To protect this advantage, they treated the details of the volta do mar as a supreme state secret. Detailed rutters sailing instructions that included depths, landmarks, and sailing directions were considered classified documents. Captains were sworn to secrecy, and the distribution of accurate charts was tightly controlled by the government's own mapping agency, the Casa da India. The penalty for leaking such information could be severe, even death. This wasn't paranoia, it was cold, hard economic calculus. By keeping their navigational codes secret, they could charge exorbitant prices and fund their empire for over a century, all while their European rivals desperately tried to piece together the same knowledge. This culture of cartographic secrecy was not unique to the Portuguese. In the Mediterranean, the powerful merchant republic of Venice operated with a similar profit-driven mindset. Venetian cartographers were renowned for producing the most beautiful and accurate Portolan charts, detailed maps of coastlines that were essential for safe Mediterranean trade. But these charts were not mass-produced for public consumption. They were incredibly expensive, hand-drawn masterpieces commissioned by and for the elite wealthy merchant families, ship captains, and state officials. Many of these charts were encrypted with subtle codes and symbols known only to their owners. A seemingly innocent illustration of a sea monster might actually denote a particularly dangerous underwater reef, while a fanciful castle drawn on a coastline could secretly indicate a safe harbor with fresh water. This encryption served two purposes. It protected the merchant's investment by safeguarding the most efficient routes from competitors, and it also protected the state's economic interests. If a rival power like Genoa or the Ottoman Empire were to get hold of an unencrypted Venetian chart, it could undermine Venice's dominant position in the trade of luxury goods like silk, spices, and glass. The map itself became a vault, and its symbols were the combination lock. This obsessive protection of knowledge had a devastating, unintended consequence: the irreversible loss of that very knowledge. When empires fell or merchant houses went bankrupt, their carefully guarded archives were often scattered, hidden, or deliberately destroyed to prevent them from falling into enemy hands. A Portuguese captain fearing capture might throw his precious rudder overboard. A Venetian family might burn their private charts rather than let them be seized by a rival. Wars, political upheavals, and simple neglect led to the disappearance of countless documents that held the accumulated navigational wisdom of generations. This is a primary reason why so many ancient codes remain elusive today. We have fragments and references, but the complete picture is often buried under centuries of intentional obfuscation and competitive intrigue. The loss is profound. We may never know the full extent of Phoenician voyages into the Atlantic or the precise details of Arab trading routes in the Indian Ocean, because that knowledge was so valuable that it was never widely shared to begin with. It was a classic tragedy of the commons in reverse, not a shared resource being exploited, but a vital resource being hoarded until it was eventually lost to everyone. This historical reality forces us to view ancient maps and navigational breakthroughs not just as scientific achievements, but as weapons of economic warfare. The quest for a faster route, a safer passage, or a more accurate chart was driven less by pure curiosity and more by the relentless pursuit of market dominance. This economic motive is the silent, powerful current running beneath the entire history of exploration. It explains why some techniques were so well documented and preserved, because they served a state's glory, while others vanished into the shadows, known only to a select few who took their secrets to the grave. The empty spaces on ancient maps weren't always a lack of knowledge. Sometimes they were a deliberate silence, a cartographic lie designed to protect a fortune. Understanding this changes everything. It means that the history of navigation is as much a story of commerce and competition as it is of courage and discovery, a reminder that human ingenuity is often shaped not just by the stars above, but by the gold that lies on the distant shore. Now let's step inside the mind of one of these ancient wayfinders, because the most sophisticated tool they possessed wasn't made of wood or stone, it was the human brain itself. We've explored the stars they followed and the tools they used, but all of that external knowledge had to be processed, stored, and utilized by a mind trained to perform feats of memory and perception that seem almost superhuman to us today. This wasn't a passive skill, it was an active, dynamic process of building and constantly updating a detailed cognitive map, a living, three-dimensional model of the world held entirely within their consciousness. A Polynesian navigator, for instance, didn't merely memorize a list of stars. He built a mental star compass, a full celestial sphere that he could rotate in his mind's eye, knowing which star would rise from which point on the horizon at any given hour of any night of the year. He would then layer onto this star chart his knowledge of ocean swells, feeling the dominant pattern through the motion of his canoe and noting any subtle interference, which might indicate a distant island disrupting the flow. He would add the flight paths of birds, the smell of the air, the temperature of the water, and the texture of the clouds, synthesizing all of this multisensory input into a single, coherent understanding of his position and direction. This mental map was never static. It was a constantly shifting simulation, updated with every new piece of sensory data, allowing him to reckon his way across thousands of miles of open ocean with a confidence that we now reserve for satellite guidance. Cultivating this ability required a form of deep learning that is almost foreign to our modern, information-saturated world. Apprenticeship wasn't a matter of reading a manual or attending a lecture. It was a total immersion that began in childhood and lasted for decades. A young student would spend years simply listening to the chants of his master, not just learning the words but internalizing their rhythms, which often mirrored the rhythms of the sea. He would practice visualization exercises on land, sitting in a circle of stones representing the star compass, and reciting the rising and setting points of hundreds of stars until he could do it blindfolded. He would be taken out on the water and taught to feel the difference between various swell patterns, to distinguish the specific motion caused by a reflected wave from a distant atoll from the dominant ocean roll. This training was as much about conditioning the mind as it was about imparting knowledge. It was about developing a phenomenal memory, a heightened spatial awareness, and perhaps most importantly, a profound and patient attention to detail. A lapse in concentration, a forgotten star path, or a misread swell could mean missing a tiny island target by dozens of miles and facing death in the open ocean. This immense pressure forged minds of incredible focus and resilience capable of holding complex, multi-layered information in active memory for weeks at a time during a long voyage. Modern neuroscience is now beginning to catch up with what these ancient cultures understood intuitively. Studies on contemporary populations, from London taxi drivers to expert musicians, show that intensive training in spatial navigation and memory tasks can physically change the brain. The famous research on London cabbies who must memorize the city's immense and convoluted street map to earn their license shows that this process actually enlarges the hippocampus, the brain's central hub for memory and spatial mapping. The constant mental exercise of building and navigating their cognitive map increases gray matter volume and enhances neural connectivity. Now, imagine the brain of a master Polynesian navigator who held not a city map but an entire ocean basin and a rotating star field in his mind. It is almost certain that their brains exhibited similar, and likely even more pronounced, plasticity. They were, in a very real sense, cognitive athletes, their neural pathways honed to a degree that allowed them to perceive and process environmental cues that would be completely invisible to an untrained person. They didn't just see the ocean, they read it. They didn't just look at the stars, they conversed with them. This psychological dimension completes our understanding of ancient navigation. It wasn't just a collection of techniques, it was a state of mind. It was the ultimate expression of a partnership between human intelligence and the natural world, a reminder that the most powerful technology we have ever possessed is the one between our ears, and that its potential is unlocked not by circuits, but by patience, reverence, and relentless, dedicated practice. Today, we carry the accumulated geographical knowledge of all human history in our pockets. With a few taps on a smartphone screen, we can summon a blinking blue dot that places us on a map with an accuracy of just a few meters anywhere on the planet. Global Positioning System technology, a constellation of satellites whirling overhead, has fundamentally transformed our relationship with space and movement. It has undoubtedly saved lives, streamlined global commerce, and made the world more accessible than ever before. A hiker in a remote canyon, a cargo ship captain navigating a treacherous strait, or an emergency responder finding a specific house in a dense neighborhood, all benefit from this miraculous, instantaneous precision. It represents a triumph of human ingenuity, a system so reliable that we've come to depend on it for everything from our morning commute to coordinating complex military operations. The gain in sheer efficiency and safety is immeasurable and should not be discounted. Yet, this incredible convenience comes with a subtle but profound cost, a quiet trade-off that becomes apparent only when we contrast it with the ancient methods we've explored. Modern navigation is an act of abstraction. We are no longer navigating the physical world itself. We are interacting with a simplified digital representation of it. Our primary relationship is with the screen, not the landscape. The GPS tells us to turn left in 500 feet, and we obey, often without noticing the unique architecture of the building on the corner, the specific type of tree shading the street, or the way the afternoon light falls across the park we're driving past. The journey becomes a series of automated commands, and the rich, multisensory experience of travel is reduced to following a pulsating line. This divorces us from the environment, creating what some call nature deficit disorder on a global scale. We arrive at our destinations faster and more directly, but we are often less connected to the journey itself, less aware of the nuances of the world we are passing through. This stands in stark opposition to the holistic awareness fostered by ancient wayfinding. For a Polynesian navigator, the journey was a continuous, deeply immersive dialogue with nature. Success depended on an intimate, sensory connection to the world, feeling the shift of a swell through the hull of the canoe, smelling the scent of land on a distant breeze, reading the meaning in a bird's flight pattern. This wasn't just a means to an end, it was a form of reverence. It required patience, humility, and a deep understanding that humanity is a part of the natural world, not separate from it. This constant engagement fostered a sustainable mindset. You could not exploit an environment you understood so intimately and depended upon so completely. You learned to take only what you needed, to move with the seasons, and to see yourself as a participant in a larger, living system. The modern convenience of GPS, for all its benefits, risks eroding this ancient, hard-won intuition. The very skills that allowed humans to populate the globe, the ability to sense direction, to remember complex landscapes, to observe subtle environmental cues, are beginning to atrophy from lack of use. Why remember the way when your phone can remember it for you? Why learn the stars when an app can point the way? The critical question this contrast invites is not which system is better, but whether we can consciously choose to integrate the old wisdom with the new tools. This isn't about abandoning technology. That would be both naive and impractical, but about refusing to let our capabilities diminish. It's about using GPS as a safety net rather than a crutch, allowing it to handle the baseline navigation while we consciously engage our senses to enrich the experience. Imagine using a digital map to plan a hike, but then turning off the screen to practice reading the sun's position for direction, identifying landmarks, or noticing how the vegetation changes with elevation. Think of a sailor using a chart plotter for overall course setting, but also maintaining the traditional skills of reading the water and the sky, understanding the weather patterns, and feeling the rhythm of the sea. This integrated approach offers the best of both worlds, the life-saving accuracy of modern technology and the profound, soul-nourishing connection that comes from truly knowing your place in the world. It is a conscious effort to reclaim our innate human abilities, not out of nostalgia, but to ensure we remain adaptable, observant, and deeply connected creatures. The goal is to become navigators who can thrive with or without the satellite signal, individuals who are never truly lost because they understand how to listen to the oldest map of all, the Earth itself. But what if the story of ancient navigation is even older and more mysterious than the conventional timeline suggests? What if the Polynesians, the Phoenicians, and the Vikings were not the originators of this sophisticated knowledge, but merely the inheritors of a far more ancient legacy, fragments of a grander science that was all but erased by some forgotten global catastrophe? This is the provocative question at the heart of alternative historical theories, which propose that the true dawn of seafaring and celestial mastery lies not in recorded history, but in a shadowy prehistory, in the time of what some call lost advanced civilizations. Researchers like Graham Hancock have popularized the idea that a vast seafaring culture, perhaps the source of the Atlantis myth navigated the globe at the end of the last ice age, over 12,000 years ago. According to this theory, this advanced society possessed a profound understanding of astronomy, geometry, and the Earth's geography, which they encoded into myths and imparted to the surviving hunter-gatherer cultures they encountered. Then, around 12,800 years ago, a series of cataclysmic events, possibly triggered by comet impacts and the subsequent rapid melting of ice sheets, caused a global flood that drowned their coastal cities and wiped them from the face of the Earth. Their great ships and port facilities were lost beneath rising seas, and their vast knowledge was shattered, surviving only in scattered fragments that would later be rediscovered and painstakingly pieced back together by the civilizations we now consider ancient. The evidence for this startling idea, while fiercely debated, is undeniably tantalizing. Look at the precise astronomical alignments of megalithic sites that predate the pyramids by thousands of years. Take Göbekli Tepe in modern-day Turkey, a complex of massive, T-shaped stone pillars carved with intricate animal reliefs, erected around 11,600 years ago by what is supposed to be a society of simple hunter-gatherers. The arrangement of these pillars appears to be aligned with the rising of certain stars, particularly those in the constellation Cygnus, suggesting a sophisticated early understanding of the precession of the equinoxes, a slow 26,000-year wobble in the Earth's axis. This is not simple sun worship. This is advanced astronomical observation. Similarly, the Great Pyramid of Giza is not just a tomb, it is a breathtakingly precise geodetic marker. Its base is aligned to the four cardinal directions with an accuracy within a fraction of a degree. Its perimeter, divided by twice its height, gives a close approximation of pi. The ratios and measurements within the pyramid seem to encode information about the Earth's circumference and its dimensions. For these theories, such precision is not the product of gradual trial-and-error development by a Bronze Age society. It is the legacy of a much older, much more advanced science of the world, a science that would have been absolutely essential for long-distance transoceanic navigation. This idea of a lost navigational legacy might also explain the most perplexing ancient maps, like the Piri Reis map we discussed earlier, which seems to show an ice-free Antarctica. Mainstream geology tells us that Antarctica has been covered in ice for millions of years, but some core samples suggest there might have been periods of deglaciation as recently as 12,000 years ago. Could the source maps used by Piri Reis have originated from this antediluvian world, from cartographers who actually mapped the continent's true coastline before the ice returned? It's a breathtaking possibility. Furthermore, we see startling similarities in myths and flood stories from cultures all over the world that are completely separated by oceans. The Sumerians, the Maya, the indigenous peoples of Australia, and the tribes of the Pacific Northwest all have their own versions of a great deluge that destroyed a previous world. These stories often speak of gods or wise ones who arrived by sea after the flood, bringing with them the knowledge of agriculture, astronomy, and law. Could these gods actually have been the surviving mariners and sages of that lost civilization, spreading their shattered knowledge to the four corners of the earth in a desperate attempt to preserve it? Of course, these theories are highly controversial and rejected by the vast majority of mainstream archaeologists and historians, who point to a lack of conclusive physical evidence. No sunken cities, no undisputed artifacts from such a culture. They argue that the gradual progression of human technology, as seen in the archaeological record, does not require a cataclysm or an outside influence to explain the achievements of the ancient world. The alignment of ancient sites, they say, can be explained by patient, long-term observation, and the mathematical encoding in structures like the pyramids could be the result of incredible skill and devotion rather than inherited knowledge. The flood myths could be folk memories of very real but local post-Ice Age sea level rises. The debate between these two views is often heated, but its true value may lie not in proving one side right, but in the questions it forces us to ask. These alternative theories challenge the rigid, linear narrative of human progress that suggests we have moved in a straight line from primitive to advanced. Instead, they propose a more cyclical view of history, one of rise and fall, of forgotten golden ages and catastrophic resets. They open the door to the possibility that our ancestors were far more capable, far more intelligent, and far more connected than our history books have ever given them credit for. Whether you find these ideas compelling or fanciful, they serve a crucial purpose. They ignite our curiosity and remind us that the past is a vast, deep ocean, and we have only just begun to explore its sunken continents. Yet for all the intellectual curiosity driving these projects, the most profound impact has been cultural and spiritual. The Hercules voyages, in particular, ignited a renaissance across Polynesia, a reawakening of pride and identity that had been suppressed by centuries of colonization. When the canoe arrived in Tahiti after its first voyage in 1976, it was met by over 17,000 people, half the island's population, weeping with joy. For the first time in generations, they were witnessing a living, powerful symbol of their own ancestors' genius, not built by outsiders but by their own children, guided by their own reclaimed knowledge. This was more than a historical reenactment, it was an act of cultural resurrection. It sparked a movement that saw a new generation of Polynesians building canoes, learning the old chants, and studying with the few remaining elders who held fragments of the knowledge. The navigator Piʻailug, who had generously shared his sacred knowledge to make the first voyage possible, did more than teach star paths. He helped an entire people find their way back to themselves, restoring a connection to their past that became a compass for their future. This empowerment through ancestral wisdom offers a powerful model for indigenous communities worldwide, demonstrating that the keys to addressing modern challenges, from environmental sustainability to social cohesion, may well lie in the rediscovered codes of the past. But this surge of fascination with ancient wayfinding brings with it a profound responsibility, a critical line we must navigate with care: the distinction between cultural appreciation and cultural appropriation. To truly honor these lost codes, we must move beyond simply extracting cool facts or romanticizing the past. We must engage with the living descendants of the people who created this knowledge. This isn't about political correctness, it's about basic human respect and historical accuracy. For centuries, the wisdom of indigenous cultures was systematically dismissed, suppressed, or outright stolen by colonial powers. Traditional navigation was labeled as primitive superstition, its practitioners marginalized and their knowledge nearly erased. Now, as the modern world finally recognizes the brilliance of these systems, there is a dangerous temptation to simply take this knowledge, repackage it, and present it as a novel discovery without acknowledging its source or context. This is the heart of appropriation. It divorces the information from its cultural soul, from the people who painstakingly developed and protected it against all odds, often turning their sacred legacy into a mere commodity or a trivial footnote. The antidote to this is genuine collaboration and reciprocity. Look at the powerful example set by the revival of Polynesian voyaging. The success of the Hokula was not achieved by outside historians studying texts in isolation. It was a partnership. It required the humility of modern sailors and scholars to approach master navigators like Piʻailug, not as subjects to be studied, but as teachers to be honored. They didn't demand his knowledge, they earned it through respect, patience, and a demonstrated commitment to using it in a way that would benefit his culture. The result wasn't just a successful voyage, it was the reignition of a cultural flame across the Pacific. This model shows us that ethical engagement means stepping back and allowing descendant communities to lead the conversation. It means asking, "How can we learn from you?" instead of declaring, "This is what we found." It involves sharing credit, resources, and platform, ensuring that the narrative remains firmly in the hands of those to whom it rightfully belongs. This transforms historical curiosity from an act of extraction into an act of restoration, helping to repair the damage caused by centuries of cultural erosion. Ultimately, this mindful approach enriches everyone involved. For outsiders, it leads to a deeper, more authentic understanding. Learning about the Polynesian star compass from a modern wayfinder who can explain the chants, the stories, and the spiritual connection to the ocean provides a context that no textbook ever could. It adds layers of meaning that transform a technical skill into a holistic worldview. For the indigenous communities, it represents a reclamation of power and identity. It validates their ancestral knowledge as the sophisticated science it always was, providing a profound source of pride for younger generations and helping to ensure these traditions continue to thrive. Decoding the past, then, becomes a shared journey rather than a solitary conquest. It requires not just intellectual curiosity, but also emotional intelligence, the empathy to understand that we are not merely studying historical techniques, but engaging with a living heritage. It is a reminder that the greatest discoveries are not just about where we can go, but about understanding who we are in relation to those who came before us and those who carry their legacy forward today. When we picture an ancient mariner, our minds almost invariably conjure the image of a rugged, weathered man squinting at the horizon, a Viking at the helm of a longship, a Phoenician merchant captain, or a Polynesian wayfinder. This ingrained stereotype, however, tells only half the story. The truth is, the epic tales of exploration and trade that connected our ancient world were not solo endeavors performed by lone male geniuses. They were community efforts, and women were absolutely integral to this success, often in roles that have been systematically minimized or erased by centuries of patriarchal historical record-keeping. To assume otherwise is to ignore the fundamental logistics of these incredible journeys and the subtle but powerful clues that have survived. Consider the sheer practicality of a long-distance voyage. A Phoenician trade ship setting out from Tyre on a months-long journey to the tin mines of Britain wasn't just a vessel carrying sailors. It was a floating village, a self-contained ecosystem that required meticulous management to survive. While the captain might have been steering by the stars, who was managing the critical supplies of fresh water, grain, and dried fish, who was tending to injuries with knowledge of herbal remedies, who was maintaining social order and morale during weeks of tense, confined travel. In countless cultures, these vital tasks fell to women. They were the provision masters, the healers, the peacemakers, and the keepers of routine, roles without which the entire expedition would have foundered. Their work was the invisible ballast that kept the ship stable, allowing the navigators at the prow to focus on the stars. This wasn't a passive contribution. It was active, essential labor that required intelligence, foresight, and skill, turning a risky gamble into a calculated, repeatable enterprise. Beyond these crucial support roles, there is compelling evidence that in some societies women took direct command. The Norse sagas, for all their focus on male warriors, offer intriguing glimpses. The saga of the people of Laxardal tells of the deep-minded, a formidable Norse queen who, after the death of her father and son, took charge of her family's legacy. She personally oversaw the construction of a ship in secret, assembled a crew of her followers, and then skillfully navigated it from Scotland all the way to Iceland, where she became one of its most powerful and respected settlers. She wasn't a passenger, she was the captain and the navigator, a leader whose shrewdness and seafaring prowess ensured her dynasty's survival. Similarly, archaeological finds from Viking-age burials continue to challenge our assumptions. The famous Oseberg ship burial in Norway, one of the most lavish ever discovered, contained the remains of two women surrounded by opulent grave goods. The sophistication of the ship and the richness of the artifacts, which included a tapestry possibly depicting ritual processions, have led many scholars to suggest that one or both of these women were of extremely high status, perhaps even priestesses or chieftains who held significant secular and religious authority, which in a seafaring culture would inherently involve knowledge of ships. Travel, this connection to the spiritual world points to another critical, yet often overlooked female domain, that of the ritual specialist. Before launching a voyage into the terrifying and unpredictable unknown, ancient cultures across the globe performed ceremonies to ensure safe passage and favorable winds. These weren't superficial superstitions, they were vital psychological and spiritual preparation. In many cultures, from the Pacific Islands to the Mediterranean, women were the primary custodians of this ritual knowledge. They were the ones who knew the chants to appease the ocean gods, the prayers to the wind, and the divination rituals to choose an auspicious departure date. A Polynesian voyage, for instance, would have been unthinkable without the blessings of the community, a process undoubtedly involving female elders and ritual experts. Their role was to forge a metaphysical link between the community on land and the voyagers at sea, providing a psychological safety net that allowed the navigators to venture forth with confidence. In a very real sense, these women were navigating the intangible forces that the sailors believed governed their fate, making them partners in the endeavor every bit as important as the person holding the steering oar. So why are these stories so scarce in our history books? The answer lies in the nature of historical recording itself. For most of history, written records were kept by men for men and about men, focusing on military conquests, political reigns, and commercial transactions, the public sphere traditionally dominated by males. The daily, vital contributions of women occurring in the domestic or ritual spheres were simply not considered noteworthy by the chroniclers of their day. Furthermore, much of this knowledge was transmitted orally, and as patriarchal structures solidified, these stories were gradually sidelined and forgotten. The erasure was not necessarily always malicious. It was often a simple byproduct of what the society valued enough to record in stone or parchment. Rediscovering these lost contributions does more than just add a few new names to the historical roster. It fundamentally transforms our understanding of how ancient exploration actually worked. It reveals that these achievements were not the product of solitary male heroism, but of complex, collaborative, mixed-gender communities. It forces us to replace our simplistic image of the lone captain with a more accurate, richer picture. A skilled navigator relying on a star compass taught to him by his elder, a sister managing the water rations, and a wife performing a ritual on the shore to ensure his safe return. This more complete view doesn't diminish the accomplishments of the past. It amplifies them, revealing a deeper, more diverse, and more fascinating tapestry of human ingenuity. It challenges us to look beyond the stereotypes and listen more carefully to the whispers of history, where the voices of women have been guiding the way all along. Yet for all the wisdom we can glean from artifacts and oral histories, some of the most profound breakthroughs in understanding ancient navigation are coming not from dusty libraries or ocean floors, but from the most advanced technologies of the 21st century. We are living in a new golden age of discovery, where tools like LiDAR scanning, genetic analysis, and powerful digital simulations are acting as time machines, allowing us to peer into the past with a clarity that was once the stuff of science fiction. These are not just incremental improvements, they are paradigm shifts, revolutionizing entire fields of study and providing hard data to test theories that have been debated for centuries. Imagine being able to strip away 1,000 years of dense jungle growth with the click of a button to reveal a vast, ancient network of roads and canals that connected forgotten seaports. Or using a genetic sequencer to trace the migration path of a single family across the Pacific by following the subtle markers in their DNA. This is the powerful convergence of past and future, where cutting-edge science is becoming the key that finally unlocks the deepest secrets of the ancient world. One of the most revolutionary tools in this new arsenal is LiDAR, which stands for light detection and ranging. This technology involves mounting a laser scanner on an aircraft or drone and flying it over a landscape. The laser pulses penetrate the upper canopy of forests and vegetation, bouncing off the solid ground below and returning to the sensor. By measuring the time it takes for each pulse to return, a computer can construct an incredibly detailed, three-dimensional map of the bare Earth, effectively digitally deforesting entire regions. This has been nothing short of transformative in places like Mesoamerica and Southeast Asia. Archaeologists using LiDAR have discovered entire lost cities and complex infrastructure hidden for centuries under the jungle, completely rewriting our understanding of the scale and sophistication of ancient civilizations like the Maya or the Khmer. For the study of navigation, this is pivotal. LiDAR can reveal ancient causeways that connected inland cities to long silted-up ports, or the remains of massive canal systems that allowed for inland trade. It can identify the subtle remains of docking facilities, breakwaters, and even ceremonial structures aligned with celestial events on coastlines that have been radically altered by time. Each new discovery adds another data point to our map of ancient global connectivity, showing us that trade routes were far more extensive and integrated than we ever imagined. At the same time, in the realm of the microscopic, genetic science is providing a stunning new narrative of human movement. Scientists can now analyze the DNA from ancient skeletal remains and compare it to the genetic profiles of modern populations. By tracking specific genetic markers that are passed down through generations, they can trace ancient migration patterns with astonishing precision. This has had a huge impact on understanding the settlement of the Pacific. For decades, historians debated the exact routes and timing of the Polynesian expansion. Was it a rapid, intentional migration or a slow, island-hopping process? Did they reach South America? DNA evidence is now providing definitive answers. Studies have confirmed prehistoric contact between Polynesian populations and native South Americans, likely occurring around the year 1200, centuries before Europeans arrived. This genetic data acts as a perfect complement to the oral traditions and archaeological record, proving that those epic voyages described in the chants were not only possible but actually happened. It provides a biological roadmap of exploration, showing us not just where people went, but how they were related to each other, painting a picture of incredible seafaring families deliberately spanning the ocean to connect and populate new worlds. And for the first time in history, we have the computational power to truly walk in the shoes of an ancient navigator. Astronomers and software engineers are collaborating to create incredibly accurate digital planetariums that can recreate the exact night sky from any point on Earth at any time in the past. We can now input the precise date of a known Viking voyage or a Polynesian expedition and see precisely which stars were visible, where they rose and set, and how the constellations shifted throughout the night. This allows us to test the oral traditions and historical accounts with scientific rigor. Was a specific star really a reliable guide for a journey to a particular island? The digital sky can tell us. Furthermore, oceanographers are building complex simulations of ocean currents and wind patterns that can model ancient climate conditions. We can take the design of a Phoenician trade ship, input the known currents of the Mediterranean, and simulate a voyage from Tyre to Carthage to see how long it would have taken and what route would have been most efficient. This moves us beyond speculation into the realm of testable, repeatable experiment. We are no longer just guessing how they did it. We are using powerful computers to model their world and virtually sail their routes, uncovering the brilliant logic behind their choices. The most exciting development, however, is not any single technology, but the new spirit of collaboration they inspire. These tools are smashing the old silos between academic disciplines. Historians are now working side by side with geneticists who are conferring with astrophysicists who are learning from master navigators from indigenous communities. This interdisciplinary approach is where the real magic happens. A geneticist might identify a pattern of migration. A historian can then cross-reference that with an ancient text, and an indigenous knowledge keeper can provide the cultural context that explains why that migration happened. This partnership is crucial. It ensures that the high-tech research is guided by the deep, lived wisdom of the cultures being studied, preventing a new form of technological colonialism where outsiders simply extract data without context or respect. The goal is no longer for scientists to simply prove or disprove indigenous stories, but to use technology as a bridge to better understand the profound science encoded within them. This collaborative model promises a much richer, more nuanced, and ultimately more accurate understanding of our shared human history, revealing that the greatest code of all is the one that connects all forms of knowledge in the pursuit of truth. Perhaps the most profound legacy of these ancient navigators isn't found in the specific stars they followed or the tools they crafted, but in the breathtaking testament they offer to the human spirit itself. Their story is, at its heart, a story of radical resilience, a quality not of brute force, but of intelligent, patient, and profound adaptability. They looked out at the greatest emptiness our planet has to offer, the trackless and terrifying expanse of the open ocean, and instead of seeing a barrier, they saw a pathway. They faced this immense unknown not with the arrogant certainty of conquerors, but with the humble wisdom of students, understanding that their survival depended on listening to the world more closely than they had ever listened before. They placed their faith not in technology, but in their own cultivated intelligence, their communal knowledge, and their deep, reverential relationship with the natural world. This combination of courage, curiosity, and humility is one of the purest expressions of human potential we have ever witnessed, a powerful reminder that our greatest strength has always lain in our ability to adapt, to learn, and to connect. This innate drive to explore, to push beyond the horizon of the known, is arguably the defining engine of human progress. It is the same spark that compelled a Polynesian family to load a double-hulled canoe with everything they owned and sail toward a star they had never visited, that drove a Viking crew to sail west into the icy maw of the North Atlantic, and that now compels us to launch probes into the depths of our solar system. This isn't a mere hobby or a pastime. It is an ingrained biological and cultural imperative, a fundamental part of what makes us human. It is the force that has driven the exchange of ideas, the mixing of cultures, and the spread of innovation across continents and millennia. Every time a navigator discovered a new island, it wasn't just a new landmass added to a mental map. It was a new node in a growing global network of humanity. Each successful voyage was a vote of confidence in our collective future, a statement that the unknown was not to be feared but to be engaged with, and that the risks of exploration were far outweighed by the rewards of connection. This timeless impulse to seek out new horizons is our species' greatest heirloom, a gift passed down from those first wayfinders that continues to shape our destiny today. In our current moment, besieged by the dual crises of climate change and a pervasive sense of digital isolation, the lessons embedded in these ancient practices feel less like historical curiosities and more like urgent instructions for survival. They model a form of deep ecological literacy that we desperately need to relearn. They understood that you cannot navigate a system you do not understand, and that you will not protect a world you do not feel a part of. Their survival was directly tied to their ability to read the subtle signs of environmental health, the patterns of fish spawning, the nesting cycles of birds, the shifts in ocean temperature. In an age of accelerating climate disruption, this intimate, reciprocal relationship with nature is not a romantic ideal, it is a practical necessity. Their example calls us to move beyond seeing the environment as a resource to be managed or a backdrop for our lives, and to start seeing it again as the living, breathing, interconnected system that it is, of which we are an inseparable part. Furthermore, their journey offers a powerful antidote to the angst of our hyper-connected yet deeply lonely digital age. A Polynesian navigator on the open ocean was the opposite of isolated. He was in constant, profound dialogue with the stars, the waves, the wind, and the wildlife. His sense of connection was cosmic and ecological, not digital. While we today can be surrounded by thousands of online friends yet feel utterly alone, the wayfinder, utterly alone on the sea, felt profoundly connected to everything. This teaches us that true connection isn't about the quantity of our links, but their quality and depth. It suggests that our modern epidemic of disconnection and anxiety might be healed not by more technology, but by a different kind of engagement with the real, physical, sensory world around us. It's a call to put down the phone, step outside, and learn to read the language of our own local landscapes, to find our own star compass in the trees, the birds, and the changing seasons outside our door. Ultimately, the greatest wisdom they offer is about the power of collective intelligence and the fragility of knowledge. No single Polynesian navigator invented wayfinding. It was the cumulative achievement of countless generations, each one adding their observations, refining the chance, and passing the flame to the next. This knowledge was their most precious commodity, and they protected it not in vaults but in communities. Its near erasure following European contact is a stark warning about how easily a lifetime of wisdom can be lost when cultures are disrupted and elders are not heard. In our world where information is abundant but wisdom often seems in short supply, their example urges us to reconsider what true knowledge is. It's not just data points on a screen. It's the lived, experienced, hard-won understanding of how to live well in a place, how to build a sustainable community, and how to face the future with courage and grace. The revival of these arts through projects like the Hokulea proves that this wisdom is not lost forever. It can be rediscovered, but only if we have the humility to seek out the elders, to listen to the ancient stories, and to value different ways of knowing. Their resilience offers us a map not to a specific place but to a state of being, one of adaptability, connection, and courageous hope, providing a timeless compass for navigating the uncertain waters of our own future. The unknown code behind these lost maps is far more than a simple historical puzzle. It stands as a breathtaking testament to human creativity and our species' unending drive to make sense of the world around us. What we've uncovered is a story of profound intelligence, a form of genius that wasn't written in books but was instead etched into the very fabric of daily life, woven into the rhythms of the ocean and the endless dance of the stars. These ancient navigators didn't see the world as a collection of separate parts. They saw it as a single, interconnected system, a living map where every wave, every bird, every shift in the wind held a piece of the puzzle. Their systems were born from a deep, intimate relationship with the Earth, a partnership built on observation, patience, and a humble understanding that true mastery comes from listening to the world, not from trying to dominate it. As we slowly unravel their secrets, we're doing much more than just solving the mysteries of the past. We're gathering priceless insights for building a more sustainable and connected future. Their holistic approach to navigation, a practice that blended astronomy, ecology, and community, offers a powerful blueprint for how we might live in balance with our planet today. In an age of climate change and environmental crisis, their example reminds us that sustainability isn't a new technology we have to invent, but an ancient wisdom we need to remember. They teach us that the most advanced system is often the one that works in harmony with nature's own rhythms, not against them. This isn't about abandoning our modern tools, but about enriching them with an older, deeper kind of knowledge, learning to use our GPS while still remembering how to read the sky. So let's carry their spirit forward, a spirit that is both fiercely curious and deeply respectful, that embraces the unknown not with fear, but with a sense of wonder and connection. Let's be explorers in our own right, whether that means venturing to new places or simply learning to see our own world with new eyes, to notice the subtle patterns and hidden pathways that surround us every day. This journey through time shows us that the greatest adventures often begin not with a loud announcement, but with a quiet question, a willingness to listen, and a courage to set sail toward the horizon of the unknown. If this exploration into history's greatest mysteries has inspired you, we'd love to hear your thoughts in the comments below. Share what surprised you most, and don't forget to subscribe so you can join us for our next deep dive into the hidden stories that shape our world.